Variation, part 1. Maybe some of you will ask, what is the meaning about variations? In math, we have different kind of variable. I use one famous example. D is equal to 3 times t. Sometimes they are variable, sometimes they are constant. Let's see one example. If the speed of a car is 20 km per hour, then this is a constant. I know the relationship between d and t is d is equal to 20 times t. Then if the t change, for example, change from 1 to 2, d will change depending on the values of t. So we will call these two variable. And this kind of relationship is variations. We have a lot of example related to the different variables. For example, I know if we have a trapezium, the upper base is A, the lower base is B, and the height is H. The relationship between the area of a trapezium is equal to A plus B times H divided by 2. You can find, area is depending on the values of A, B, and H. If they are all variable, this is also a variation between these four variables. Let's see another example, page 2. In this topic, we'll only discuss 4 special variations. The first one is direct variations. This is one of the direct variations example. It is given that every block of chocolates has 28 kcal of energy. N is represent the number of block of chocolates. So N is equal to 1, the energy is equal to 28. N is equal to 2, the energy is equal to 56. It's not very difficult to fill in the table. N is equal to 3 and the energy is equal to 84 and 112. And this is the relationship between these two variables. I know the relationship between N and E is equal to 28 times N. This is one of the examples of direct variations. Why? Because we find E over N is equal to 28. Help me to change it. This is E over N. It's equal to 28. It's equal to a constant. If these two variables, we divide it, and then this is a constant, this relationship is called direct variations. In other words, when E increase, N will also increase. So if you see the questions, describe the relationship between y and x like this. Y is varies directly at x, or y is directly proportional to x. That means y over x is equal to a constant. So we'll use this form to represent y is equal to kx. In math, we can use this symbol to represent the direct variations. This notation, that means y is directly proportional to x, y varies directly at x. That means y over x is equal to a constant. X over y is also equal to a constant. So let's see example 6. Example 6.1, easy questions. Suppose y varies directly as the square. Remember, it's square root, is not square. So you can write down the relationship between x and y like this. Y is equal to k times square root of x, where k is a non-zero constant. Remember, must be non-zero. If k is equal to a 0, Then x increase, y will not increase is also equal to 0. So k must be non-zero constant. And one of the given information between x and y, when y is equal to 20, x is equal to 4, then you can substitute y is equal to 20 and x is equal to 4. Why? Because I want to find an equation connecting y and x. This is an equation, but not only connecting x and y, but also k. So you need to find the values of k. I know k is a constant. According to the given information, I can find the constant k. Then 20 is equal to 2k, k is equal to 10. So I know y is equal to 10 times root x. This is part A. Part B. Find the values of y when x is equal to 16. Easy. Substitute. X is equal to 16. 10 times root x, 16. So it's equal to 40. Done. B2. When y is equal to 30. What is the values of x? 30 is equal to 10 times root x. Divide 10 on both sides. Square root of x is equal to 3. Take square on both sides, and then x is equal to 9. So you can turn to page 3 to do the for exercise 1. Remember, pause the video, do it by yourself. Part A. Suppose y varies directly at x to the power 3. And one specific case. Then you can set up y is equal to kx to the power 3, where k is a non-zero constant. Substitute the information, you can find the constant k. K is equal to 5. Part B. Similar. When x is equal to 4, what is the values of y? Then y is equal to 5 times 4 to the power 3, y is equal to 320. When y is equal to B2, y is equal to 1080. Substitute to the equation. Not very difficult to find the values of x. Pause the video to do the for exercise 2 first. For exercise 2, y is directly proportional to x squared. Give you one information. Find the values of y when x is equal to 2. Same idea. Set up the equations with unknown k. Substitute the information to find the values of k. After that, substitute x is equal to 6. You can find the answer. Page 4. Maybe you can do example 6.2 first. I want to discuss with you tomorrow. And example 6.3, I want to demonstrate how to do it. Okay. This is a different type of questions related to the direct variations. It is given that Q varies directly at the square root of W. So I only know Q is equal to K times square root of W. You can see we do not have any information to find the values of K, but I need to find the percentage change in Q if W increased by 44%. That means we have new Q. When W increase 44%. Remember, if increase 44, the percentage factor, the factor must be 1 plus 44%. And this is 1 plus 44%. If we need to find the percentage change, the basic method, we need to use the new minus the original over the original times 100%. Then you can simplify it. This is equal to the square root 1.44 times k times square root w minus k times square root w over k times square root w. Substitute the original values. And then you can take out k times square root w. So you can take this 2 out. Remain 1.2 minus 1 over k times square root of w times 100%. So the answer is 20%. So the conclusion is Q increase by 20%. Now your turn for exercise 3. Do it now. Pause the video. Okay, the question gives you the information. Y varies directly at x squared if x is doubled. Find the percentage change of y. So you can set up the relation between x and y in terms of k. Y new, x is doubled. One of the common mistakes, remember this 2 is inside the square, just like the previous one inside square root. So you need to take square for this 2 is 4kx squared. And then percentage change. New minus original over original times 100%. Same idea, take out the common factor kx squared. Remain 4 minus 1. Okay, remain 4 and 1 over k squared. Pause it out, and then the answer is 300%.